Okay, so on your desk you have a set of note cards, and just real quickly with your groups, I want you to match the vocab word to the definition.
And we will go back to that later on, and you will have a check on learning. But right now we're just accessing your prior knowledge of what you know about plate tectonics. About 20 more seconds. Want to get our cookies?
Okay, so okay, we'll give you like 5 more seconds.
Okay.
All right, today we're going to be talking about plate tectonics. Our central question today is, how does plate tectonics affect the shape of the Earth, and do you think that the Earth is still growing? So those are some things to think about as we teach this lesson. So when the Earth was forming, land masses from volcanoes deep in the oceans created a mass continent known as Pangaea. And developed from the 50s to the 70s, plate tectonics are the modern version of continental drift. And this theory was first proposed by scientist Alfred Wegener. How do you pronounce it?
He is German, so the W is a V. Wegener.
And that was in 1912. And then so what we're going to go over today are 3 types of plate boundaries named divergent, transform, and convergent.
And look at your cards and see how many of you got them right. You got them right? You got them right? All right, we'll see. Okay, the very first one, you're going to take your top cookie and on each 3 of them and crack them in half. And then lay them back on top of your cookie just like so. Take the top layer of your cookie, crack it in half, and place it right back on top of your cream. Your lithosphere. And put it right back on top.
Alright. Crack it in half.
Crack it in half. You got it? Does everybody have at least one done? All 3 of them. Just the top cookie should be cracked in half. All 3 cookies should have the top layer cracked in half and placed back on top of your cookie. You're going to practice each plate tectonic function. All right, so the first one we're going to cover is the divergent plates. These are 2 tectonic plates that move away from each other. So you should have your cookies slide away from each other to where you have the cream in the middle. And this would simulate a ridge where molten lava comes up and spreads the 2 plates away from each other. Can you think of any ocean ridges known?
Mid-Atlantic.
The Mid-Atlantic.
Nice job. That is a classic example of a divergent ridge plate boundary. And you guys can place it by your card just so you have a visual with what the definition is. And then the second one is convergent plates.
So take one of yours and press them together until they pretty much crash into each other. And a convergent plate are when 2 plates collide together. So you should have your lithosphere or your cream kind of smushing up on top of the other one. It should be kind of funky looking. And this can happen on land or sea. On land, it builds mountain ridges, and underneath the water, it actually is when a subduction zone is formed. So the land is the same density, so they will press up against each other. And if it's in the ocean versus a continent, one will subduct and go underneath, which is the ocean boundary, because it is less dense.
Can any of you think of a convergent plate boundary? Mountain range? The Delta Mountain range?
Come on. Okay. The Alps.
Nice. Those are good examples. The Himalayas and the Appalachian Mountains are good examples of these types of plate tectonics.
What do you think it means by an active?
Still means like earthquake happened a lot too. Like they're still coming together.
It's still coming together, right? And ancient. Remember how we talked about Pangaea and everything was all once? Well, the Appalachians are actually the same mountain ridge that is in Africa. So if you look at the coast of Africa and you look at the coast of the United States, they will fit together like a puzzle And the Appalachians are remains of when they were all at once, and they are no longer converging together.
And the third type is transform.
So you're going to take one and slide it like this. You shouldn't see any cream. They should be slide just like this. And this is a transform. The transform slide past each other, making a fracture zone. These transforms are called faults. And these are also the most extreme earthquakes, because the land shifts dramatically all at once. So when it hits, it will go seriously from one, and it'll just crack, go down. This is why faults are pretty dangerous to live near and on. And can you think of a fault that is very active in the United States other than Q? San Andreas.
That is correct. So now we're going to go over after you place all your examples by the correct definition, just so we make sure we understand them. The essential question, how do plate tectonics affect the shape of the Earth? Can anybody answer that?
Plate tectonics move the continents around the Earth super slowly, but over millions of years.
And it's good to know also for seismic activity, as far as where you're going to place buildings and infrastructures, as well as where you will live, where you will drill for those that go offshore drilling and whatnot, because you don't want to be near a hydrothermal fault.
And then, do you think that the Earth is still growing today?
Yes. Yes. According to NASA, they use a radar system that scans Earth, and they have shown that 0.004 inches or 0.1 millimeters per year, which is the average thickness of a hair, which is not relatively statistically relevant, but it is in fact showing that today it is still growing. And if you think of the Earth's age, relatively, as far as like the planets and stuff goes, 4.6 billion years. So if you take that over a time frame, you will see that the Earth not only has grown, but will continue to grow. That's
That's what we got.
Now you may eat your cookies if you want to. You got it? I bought cookies.
What? I was about to ask the whole
Here.
Give them all to do it.